Okay. So sharing my screen now. Okay, hello everyone. Hope you can hear me loud and clear. Uh,
Yeah, I
I'm
can hear
Sean
you. Good
Peter.
afternoon.
Good afternoon. How's it going?
Fine. How are you too?
I'm very fine. I'm very fine.
Great. Thanks.
Welcome everyone to this lesson today. Welcome Babatunde. Please, if I don't get your name correctly, please pardon me for today. So welcome Babatunde. Welcome Odoro. Welcome Okoro Victor. Welcome Tole. Welcome Edidion Celestine. Hope you guys have a wonderful day. So today, before we start the lesson properly, the lesson of today properly, I'm going to briefly take you on what this whole training is all about. So a lot of people applied to my DM and was asking me some things about IoT and what they want to do with it. Although it's okay to start firing, but at some point, just flying from a zero level straight to maybe advanced level without really understanding the real basics of how things work can be a little bit crappy and a little bit funny. So I'm going to take you through on what really this particular lesson is all about. And then from there, you'll be able to understand and take this lesson very important. So I'll be taking you today on IoT careers and skills. So I'll be taking you on IoT careers and skills. So the main essence of this particular lesson is that we have an agenda of what we are going to talk about today. So part of the agenda today will be talking about what IoT is all about. Now, in the last class, our trainer made justice to telling us some things about IoT. So I'm not going to dwell much on this. I'm just going to move forward to most of the things we can use it for. So we'll also try to look at the market, the IoT market. Why is it necessary? Why are you learning this? What's the equivalent of what you're learning today? Or what's the cost implication of what you're learning today? That's what I'm going to take you through. And then I'm going to talk about the careers and opportunities in IoT. So when we talk about careers, we talk about different spheres or different aspects of IoT. IoT is not just it's a very big field, just like you have engineering, where you have electrical electronics, you have telecommunications, you have a control system. It's a very big field, and then there are lots of other courses or other fields that come in play. We even have people that design UI UX in IoT. You can imagine that. So next you're going to look at is what are the skills required for an IoT engineer? So you said you want to do IoT. What are the skills required for you to successfully carry out IoT applications and then take it to the end? And by the way, I'll be constantly looking at the chat. So if you have any questions, you can drop it at the chat menu, and then I'll call you up, or maybe if you have something you want to make it to the audio, I can call you up to ask a question, or I can just reply from the chat. Then after talking about the skills required to be an IoT engineer, we'll talk about what people want, what companies want from an IoT engineer, what are the screening talents for IoT. And then we'll also talk about the roles of an IoT architect. Everybody has their part to play, everybody has a role to play. So I don't know if we are all ready, but if you're ready, I'll just go to the comment section, just go to the chat button and then just drop in some emoji, just give me some thumbs up at the chat button to know that we are all ready to start the class this evening. So can I see the first one? Who's going to be the first person to give me a thumbs up? All right, I've seen someone. I've seen Daniel Etudo. I'm waiting for some other person. Okay, I've seen Sule there. Give me a thumbs up. That means you're ready to go. Any other person? One or two more thumbs up, then we'll start the class. All right, good to go. I've seen good to go. Oh, Doro, I've seen you. Good to go. All right. Okay, Okoro Victor. So let's jump in and then let's start this properly. So what is IoT? All right, trainer last week talked about IoT. I'm not really going to dwell much about it, but I'm going to talk about IoT based on just some block diagram I was able to put up. And please, if my audio is not good enough, please just drop a chat and then I'll get it through. Okay, so I'm just going to talk about IoT based on some block diagram I was able to put up. And what am I talking about? What am I talking about? I'm talking about first, what do you want to do, or what is it all about? Okay, I want to do IoT. What am I solving? Now, the main essence of IoT is to solve a problem. So what problem are you solving? You need to know the problem first before you think of, okay, is it going to be IoT or is it not going to be IoT? And then once you're done with that particular problem, we've been able to talk about, you've been able to detect the problem you're solving, then you'll be able to talk about the data, okay? From there, what data are you getting? What data are you acquiring when trying to solve this problem? Okay, when we talk about data, we are talking about it can be either voltage, it can be current, it can be resistance, it can be any data that you are getting in order to solve this particular problem. Then once that is done, you're able to achieve the data you're getting, you're able to identify the problem you're solving. We get to the next thing, which is the context. So now, what is the context here? The context is just basically the circumstance that forms that particular setting or for that particular event or idea, or maybe terms in which it is used for. So for example, let's just check the house. You want to design a device that can constantly monitor what you are doing at home. So that basically can be your context. And then the problem there, what really is the problem there? The problem is, okay, I sometimes get to forget turning off my fridge, or I sometimes get to forget doing a particular thing. So what do I need to do? I just need, that's my problem, and then I need to solve it. So what's the data am I going to accumulate? Am I going to acquire? So this data may be voltage. Okay, I need some voltages to sense, okay, if my fridge is on, yeah, it needs voltage to run. So what amount of voltage am I looking at? Then the situation. Then once that is done, we're able to get that. It now goes into the next phase, which is the action. So action there is what should be done when you're able to, when you've seen the problem, when you've been able to detect the data in which you're acquiring, or the context in which it's used. So what should be the action? So action is, am I putting an actuator, or am I putting just a simple transistor to do the switching? Or what am I doing to do this particular action for me? So that goes into the action part. Are you switching the circuit, or what are you doing? Are you monitoring the circuit, or are you taking log of the circuit when you've been able to get this data? So that basically defines what it is. And then it is just a way devices, components work without human intervention or without human interaction. So you're able to get this problem, you're able to detect this problem, you've gotten the data, you've gotten the context, you've gotten the action, and this is done without human interaction or human any human interfacing. That is IoT for you. That is IoT for you. Now, what really ask, what is this IoT really built up around? So IoT is really built around artificial intelligence, okay? Although there are some school of thought that would argue this particular fact, But when you look at the slide in front of you, you have the environment, and then you have the other part of it that is doing the thinking, that is doing the smart decision. And then you don't necessarily have to be there. There's some other thing. Maybe there's a cloud service running somewhere, doing the smart decision, taking the smart decision. Okay, when a particular voltage is of this, no, I have to do this. So let's take a particular example. The environment where you are, your house, and then there is you have a network, and then you have some devices that senses the temperature. Let's just say a thermostat that senses the temperature, and then it can set that reading the data, maybe either voltage or whatever. It can take it either as voltage or as whatever, and then pass it through a wireless. When it pass through a wireless communication, it can either go through maybe a JSON format or whatever format you want to pass it through, and then you are able to build the content, and then you send it to a particular, you can send it to a cloud. There, the cloud there, they begins to decide, okay, now this temperature is very high, and then from what was said, no, normal room temperatures to be between let's just say 16 degrees Celsius, assuming, or maybe 20 degrees Celsius. So with this temperature I'm getting, so there should be a command. So there should be something should be done in order to bring down this temperature or to increase the temperature. That's when a command is sent. And when the command is sent, it goes back to the environment. And what does it do what does it do in the environment? Okay, what is done? What is in there? What kind of control? Is it a fan? Is it an air condition that I need to control? And then what happens is either trigger on or trigger off any of those devices, depending on the action it's taken. All right, if it's to reduce the temperature, it may decide to just turn it off, trying to reduce the temperature, or maybe turn it on, depending on what the decision is. So once that is done, that is just what we could say that is where IoT, what IoT is built around. Then in the last class, I talked about this particular slide, and then it's one of the things that was keeping me thinking a lot. And then we talk about the intriguing IoT market. What the IoT market is, each day is growing vast. And then this is a statistic by VXChange, okay, that I got this statistics from them, where they talk about IoT and other connected devices. So they say that by 2025, there's going to be about 64 billion IoT devices by the year 2025. And this is the year 2022. And we've seen a whole lot of connected devices. Houses are becoming smart, houses are becoming smart, cars are becoming smart, phones are becoming smart, a lot of things are becoming smart. So by the year 2025, they say that we are going to have about 64 billion IoT devices. So what does that mean? That means we need people who will be designing this device. We need people who will be engineering this device. We need people who will be installing this device, and we need people who are going to program this particular device. Then it says that company could invest up to $15 trillion in IoT by the year 2025. Whoa, this is huge. We've seen what Elon Musk is doing with Tesla, and we've seen what Mercedes are doing with their vehicles, and they are very smart. And the whole system of self-driving, which gets data from the environment, sense if there's a passenger sense if there's a passenger or there's someone passing by, sense everything. So by the year 2025, they said a company is going to spend up to $15 trillion. So it calls for this is a very good market anyway, and it calls for people to key in. And then it says that over 60 of US cities are investing in smart cities, IoT technology. Yes, that is ongoing. Well, Nigeria, in Lagos, they're about just based on this, that the statistics is just from YouTube. I saw that about I think about 5 or 4 cities they are now making it to be smart. So that it's even happening in Nigeria. So who are building this thing? Are we just going to be importing them, or are we going to be building these things ourselves? So it's also said that 9 out of 10 senior executives in technology, media, and telecom companies say that growth is critical to their business. So IoT growth well in a lot of companies. They say this is because um, engineers, people doing the work, we don't really have IoT engineers. We don't have a lot of them. And then US is already short of programmers. So by statistics so online, they are already short of programmers, and imagine Nigeria. So now in the by 2020 that just passed, about 90% of automobiles will be connected to the internet. Already that is happening. And thanks to MTN that is trying to bring in 5G to Nigeria. And also that about 3.5 billion cellular IoT connections is going to be done by 2023. And by 2021, which that last year, 80% of retailers will be using IoT to customize their store visits. Already that smart purchase is ongoing, online purchase. You just stay at home, log into a particular seller, and then you buy your thing, and then it's delivered to your home. How smart is that? Then over 80% of industrial manufacturing companies are using or planning to use IoT. And this is really happening a lot in the oil and gas. The oil and gas, they are fast growing, and they are trying to adopt IoT, especially when the pandemic came, and then they saw that the people coming to work is not really helping them. They need devices that could be sending this data to wherever they are, and they could be logging them to their servers. So with this data now, ask yourself, where do you find yourself, or what do you want to achieve with this data now? What do you want to achieve? Do you want to key in? Do you want to be an IoT engineer? Do you want to be a developer? Or do you want to be the man behind the things working? This is the question you need to ask yourself. Then, what are the opportunities in IoT? There are vast opportunities. There are lots of opportunities in IoT. Now, I talked about the environment, which has to be where you are, which handles the things. Now, if we should go back to the very first slide I presented, permit me to go back. You can see this thing that looks like a socket. Yes, actually, this is produced, okay, by CodeHouse, and already it's soon to hit the market. So there are a lot of the work behind it is very it's deep, and a lot of things are happening behind it. So this is one of the IoT devices that we are about to launch out. So when we talk about IoT, we should get to understand that really we understand what we are talking about. Then talking about the environment, that's something that is going to be in your environment, maybe sensing your device, connecting to your Wi-Fi. And talking about the Wi-Fi, it can be any of the protocols you can use. Like maybe you have the BLE there. It's one of the IoT devices that are out there in the market. Zigbee is one of the Wi-Fi, one of the IoT devices that are in the market. You have Wi-Fi, and there's another one called LoRaWAN. LoRaWAN is also in the market. So all of them, they go under the Ethernet, 5G, FTH. They all go under the internet, and then once they're done, they upload this data to the internet, to the cloud, and then that's where you have the backend developers, the front-end developers who come in to pick those particular APIs, those particular data, and then transfer it to maybe a human interpreting machine, so that a human can really understand. So you can have your app like the Google Home. Okay, you've seen the Google Home app. So you just pick up your app, and then you say maybe, hey Google, and then something is doing. Or maybe you're using iOS, you use Siri, and then you just pick a word, and then something is done. That is done by those people who pick the data. Those are the back-end developers or the front-end developers who pick the data and then communicate with those data. So we have a lot of people, a lot of opportunities in a lot of careers in IoT. Talking about the domain experts, people to really set up this domain for the IoT to run. We also need embedded developers. When I talk about embedded systems, and our trainer is going to talk about that today. So please take today's study very, very serious. And then we are also going to talk about big data developers, people who handle data, a lot of REST data. We need people like that. You need data scientists, those who can analyze data. We need UI app developers, people who can design the user experience interface of a particular app. We need OT specialists. We need networking engineers. We need integration engineers. We need UX designers. You need installation engineers. You need IoT architects, security and trust developers. Well, I'm an embedded system developer. Okay, I develop embedded systems and also into integration. I'm also an integration engineer and also install engineer and also part of the IoT architect, but not much of the security part of it. So you are lucky, and then you're in the right place anyway. You're right in the right place. So let's get in the next slide, and then let's talk about the primary skills you need. Okay, the primary skills that is required for you to do IoT, or for you to be an IoT engineer. Now, you need just a basic education knowledge, maybe either electrical and computer engineering or computer science, or maybe UI, UX. There's some that a lot that are being put into this slide because of space and time. So you need to understand networking, cybersecurity, a whole lot of things like you need to understand the web, those who are doing front end, those who are doing back end. At least you need to have a concept of what these parts. Also, you need sincerity and teamwork. Okay, sincerity and teamwork. If someone could ask, so what's bringing, why sincerity and teamwork in this particular thing? Okay, someone could ask, why sincerity and teamwork coming in here? Well, sincerity and teamwork really is really because you really need to know the ability to work with other people. You're not going to work alone. You'll be working with other people. You're working with other techies, with other engineers. So that teamwork, to communicate, to coexist with other people, you really need that. And then the ability to learn independently. So your ability to do research, make your findings, come up with a particular solution to a particular problem, you really need that. I also need networking and security. We also need to understand networking and security protocols. You don't want to design something for a user and then someone buys the gadget, get back home, and then while trying to use it, maybe a neighbor is having access to his house. Or maybe he just said, okay, hey, whatever app you're designing, turn on the light, and then the light came on. And after some time, maybe the neighbor who has an access to that could also turn off the light. So you need security. You need to understand networking and security protocols so that people don't breach into other people's privacy, your client's privacy. So you really need to understand that. Also, you need to understand programming and debugging. Maybe you need to understand programming. You can't do without programming. When it comes to you can't do without programming. So you really need to understand programming. The programming languages like C, C++, Python, Java, assembly language, as many as possible, you really need to understand. Then that's for those doing the hardware. When I talk about the hardware, I'm talking about the thing itself. Then talking about people at the back end, maybe you need to understand PHP, you need to understand maybe Laravel, you need to understand maybe which other one, maybe Python there. Okay, you need to understand, or maybe Node.js, you need to understand some of those things to be able to run. And when you understand programming, that's when you'll be able to know which of the protocols you're going to call. Okay, which of the communication protocols you're going to call. Okay, are you using a co-op? Are you using MPC? If you're using MPC, then you know you need a broker. It can be Mosquito broker, it can be any broker anyway. Or are you using HTTPS or HTTP, or are you using Modbus? So with this, with the programmer, your skills of debugging, you'll be able to know which of the communication stack protocols you use in order to make your device very efficient to your customers. And they also need to understand software design. Software design is very important. You also need to understand software design. So just by the side of my slide, you see something. This is just the application layers, okay, in the OSI model. So it tells you where you're placing a particular thing. Okay, am I using Modbus? Which of the layer am I placing this? Or am I using TCP? Which layer am I placing it? Or which am I using Wi-Fi, LoRaWAN, 5G, BLE? Which of the layer I placing it? You really need to understand how the internet works. You really need to understand how the internet works. It's one of the key designs to IoT applications. It's one of the key designs to IoT applications. So you really need to understand how the internet works. So we want to be able to understand all this. You can decide to go deeper into the expertise of any of these. Maybe electronics and embedded systems. We can go deeper into electronics, getting to know how to bring different components together, bring a transistor, bring an IC. When I talk about IC, I'm talking about the printed circuit. Bring a transistor, bring a diode, bring a resistor, bring a lot of components together to form a particular circuit. And then once you're done forming a particular circuit, how can you write a software to that particular circuit? That is electronics and embedded systems. You have you're using maybe one of the microcontrollers, maybe or microcomputers, talking about Raspberry Pi, Orange Pi, as the case may be, Jetson Nano, or maybe you're using Atmel series, or you're using 8085 series of microcontrollers, or you're using PICs, PLCs. Any of these, you need to understand how you write programs how you're able to write programs so that it will be able to work the way you want them to work. Then you also need to, you can also take a deeper lesson into networking and wireless protocol development. Okay, you can take a deeper lesson into that, get courses and get to understand how networking is being done. How can you link a particular computer, a computer device to another computer? Or how can you have a node? When I talk about a node of devices, I'm talking about an interconnection of more than one device in that place. So how do you network? How do you connect them? How do they talk to each other? So that's the networking and the wireless protocol developer. So you can also go deep into communication and data security. So the data that is transmitting from my house to my server, how secure are my data? Or for example, I have an IoT camera in the house, and then I'm monitoring what is happening in the house. How secure are those video feeds? Okay. If someone should peradventure breach into our system, could know what is happening at our home, and then we could be robbed. So you don't want that to happen. You really want to understand how people's data are being managed, how people's data are being saved, and how they are being used. You need to understand that. And you also need to understand big data platform development. A lot of people go into analytics, that is data science, or ML, that is machine learning or deep learning, trying to make these devices to be as intelligent as possible, like close to zero human interference, okay, close to zero. So they know when you're coming back, or they know when you're coming back, like my house, it knows when I'm coming back, and then once I enter the street, already the inverter turns on if there is no utility power, and then the inverter gun is going to turn on, and then it's going to set the room temperature for me. And then once I get into the house, I don't have to start running, turning on this, turning on that. It knows my pre-settings, and then once I'm just close to a particular route using geolocation, it just turn on the things in the house for me. And then I go in there with ease, and then I just continue my work. So you also need people who can develop apps, because some of these things interface with apps. It can be an iOS app, it can be an Android app. So some of these devices, they interface with an app. So it can be either mobile, it can be web app. You need to see what is happening. You need to have an eye on what is happening to your devices. Or maybe, for example, you're having a video feed. So you need to know what the content of that particular video. You need to see Okay, or what point did I have with someone break into my house? You need to see the timestamp too. You need to see everything. So that's where the app development, either mobile or web development comes in. And also, just you can also take a deeper lesson into digital APIs and gateways. You need to know how to fetch data, how to push data to a particular site or to maybe to a particular backend, and how to break data, just basically read and how to read and write data in a secure format. And also, you may also want to go into industrial experience when we're talking about manufacturing, talking about healthcare, talking about retail, talking about smart cities, and etc. When I talk about healthcare, before last, we were hit with COVID-19, and a lot of people were just running around, and they will need people to design something that could help us or prevent that. So you can come in there and design maybe an IoT platform that can solve that particular problem. So what are the screening for IoT talent? This is the main plea I think you really need to pay attention to. What are companies looking for? What are they looking for when they talk about IoT? What are they looking for? So you say you're an engineer. So what is expected of you? Okay, what should you do or what should you not do? So that is what I'm going to talk about now. So a lot of companies need people who have a deeper understanding to the internet. Okay, you need people who need a deeper understanding of how the internet works. People who can use TCP, people who can use IP suite, people who can use any protocols to work with devices, people who can address devices, people who can route, and people who can troubleshoot. So you said, okay, I'm an IT engineer. They need this from you. They also need people who can do networking, who can program, who can do a system integration, maybe either using any of the protocols, HTTP, MQTT, CoAP, XMPP, maybe AMPQ or Modbus. Now, the whole of these will be made known when we get deeper into the class, maybe in the second month of the class. You're going to understand a whole lot of this. So they also need people who can understand cryptography, symmetric and asymmetric, and hashing algorithms. Basically, algorithms. People who really understand algorithms. How a sequence of work, where does the work start, where does the work end, what's the workflow. So they really need people who understand this. Company needs people who can really understand it. They don't want to employ you to start. The reason they employ you is for you to do some of the uplift some of the burden from them. So when they employ you and then you start asking them so many questions, yeah, they don't need that. They also need people who really understand security protocols, TLS, IPS, IPsec, etc. There are a lot of security protocols out there. They really need people who can really understand that. They also need people who can exchange management protocols. They have the IKE version 1, version 2. They have a whole lot of one. Then you have PKI, you have PGP, and a whole lot of management exchanging management protocols out there. They need people who can understand this. They need people who understand wireless security protocols. Okay. They also need people who can handle authentication and authorization. So you need people just like you putting your password and username. So how secure is you putting in your just a password and username? Should it be a two-way authorization or what? You need to choose which one you are going to use, or maybe people into electronics and embedded system programming, the electronics and embedded systems. I'll talk about this. You need to understand how to program microcontrollers. You need to understand microcontrollers architecture, from microcontrollers to microcomputers, as the case may be. You need to understand how they work. So they also need people who can work with devices and machines. They also need people who can work with devices and machines. So yes, you just have to learn. Just have to learn about this. We're talking about SCADAs and the case may be. So you really need to learn about that. And then they also need people who can work with LoRaWAN. LoRaWAN is a long-range device that can help you access internet. It's just a long-range device. LoRaWAN is Yes, it's a long-range technology. So you have a whole lot of them there, like the big folks, they're all there. A lot of them are there. You have the 5G is even there. So maybe the version 2.4 of the Wi-Fi or version 5G of Wi-Fi, anyone you're using, you really need to have a deeper knowledge of these. Then IoT service framework. IoT service framework talk about maybe the whole platform itself, and then big data, knowledge of data science, application development and integration, software design in real time, object-oriented design, security by design, and everything. They also need people who can handle design thinking for IoT. This is key, design thinking for IoT. Like before a device is even done, okay, they need people who can think about this device, the end product of it. They call it, okay, they have called the end-to-end users, okay, end-to-end testers, and then you only need to think from the beginning of this particular application to the end of it. And also talking about agile development methodologies and also excellence interpersonal and relationship building skills. This is key. Every company needs someone with good relationship building skills. Every company needs that. So now I'm just going to talk about this before I move you. I'll let your tutor take over from here. So now there is a community we have here organized by a Codehouse called the IU Tech Quest, and this community is basically built for IoT enthusiasts. Okay, so it's also a Slack channel. At the end of this, I'm going to drop a link on how we can have access to that particular channel. Now, in that channel, there are lots of experts in that channel who are there to, if you have any questions, you have any problem, they're willing to solve. There's a job channel there in that particular Slack that if you're really good, we now add you to that job channel. So when there is any job, any IoT job, you see the notification first hand. So at the end of this, I'm going to drop the link so you can just go through it. I think one of the mentors in that particular channel is the CEO of a big company in Germany. Okay, and my mentor is also part of my own mentor is also part of there. Is also part of that channel. So a lot of big people are part of that very community. So they are all there to help out. So I'm going to drop a link on the Slack channel, KodeCamp Slack channel, IoT channel. So from there you can register, and then feel free to just ask the questions to anybody, and then it will be made known to you. So my reference from most of the things I got, most of the pictures I got from, okay, some of them were from Tuya. Tuya is one of the leading IoT companies. Other fruit is an open source. We have FlexShare, who is also helping who is picking on the platform, and then Nebukasa, which I'm partnering with, and then also Codehouse, where I'm working. So I'm going to pause here if there is any question. Okay, just like 2 minutes. If there is any question before I call the trainer to take up from here. Is there any question? If you have any questions, can you just raise? Can I see your hand? Just raise your hand. Is there any question? Am I seeing some? Is there any hand there? Okay, so I believe you everybody got the lesson right. So okay, so I've seen a question here by let me just check up your question. And it said, all of the qualifications mentioned, would they all be covered in this program? Well, this is the beginner's level. Okay, we're all in beginner's level. So we have beginners, we have intermediate, we have advanced. So at the beginner's level, we are going to cover as much as we can for the beginners level, okay? And then when you get into intermediate class, when you get into intermediate class, that's when you get to understand deeper, and the advanced also deeper. So we are going to cover some, though not all, okay? When it comes to the programming aspect of it, we are not going to cover it in the beginner class, but we are going to cover that in the intermediate class. At the beginner class, we're going to let you understand how different components work, what are the function protocols, and everything behind the scenes. So that's what we are going to make you understand. So any other question? All right. So at this point, I'm going to call our trainer to take up from here. I'll just be on the chat, so I'll still be answering. If there's any question, just drop it on the chat. I'll still be looking up. Okay, Mr. Sunday, are you there?
Yes, I'm here.
All right, all right, all right.
Can you stop sharing? Okay. Okay, are you all seeing my screen?
Yes, you can see your screen.
Yes.
Okay, okay. Okay, just like Mr. Jason mentioned concerning IoT, you need embedded system in order for you to fully work with IoT system, because it requires the interconnection of things together. Electronic systems, non-electronic systems, you can interconnect them all together. But for you to fully understand how the IoT system works, you need the knowledge of an embedded system. Well, one of the person asked that the requirements are too much, that which of the system can you start learning for now, so that you'll be able to progress? Well, it depends on your ability. Just pick anyone and start learning from there. You can start with embedded system, understanding how it works, as we are going to discuss now. With that, you'll be able to flow and understand the working principle of what you need in order to develop an IoT system. So first, what is a system? That is the first thing you have to understand. What is a system? Now, a system in this context of embedded system is an arrangement of physical components in which all the assembled units work together as a whole according to a set of rules. I want you to pick out some points in this definition of a system. The first point I want you to extract is that a system is an arrangement of physical components. Secondly, these components of a system, they are all assembled together in order to work as a whole, following some set of rules. So what and what today refers to these systems? Example of system, your phone or your laptop that you are using to connect to this Zoom and listen to this lecture is a clear example of a system. Inside your phone, the components that is used to build, that makes up the phone, the components are well arranged, and each of the subunits, they all work together in order to function as a whole. That is to form a bigger, large system. So your phone is a system. In fact, at most times you have been hearing people refer to laptops as my system. So this is a system because of the arrangement of those components and how they are working together as a whole. Even your calculator, printers, your watch you wear, they are all systems. Now, understanding fully what is a system, now let's understand what is an embedded system. First, we want to understand, embedded system. Sorry, let me move this thing away. Okay, sorry for that. So the word embedded means something that is attached to the system or built into the system. For something to be embedded, it means that particular thing is attached to a system or built into the system. So it's embedded in it. So embedded system now refers to a microcontroller or a microprocessor-based computer hardware system, which is designed to perform a specific task. It can either function as an independent system or as part of a large system. So we also want to pick out some points in this definition so that you'll be able to understand it in your fingertips, an embedded system. So first, embedded system is a microcontroller or a microprocessor. Well, we are going to learn more about this as we progress. A microcontroller and a microprocessor, they are just like the brain of the system. Look at them here. This is an example of a microprocessor, and this is an example of a microcontroller. Now, if you look at in your system, in your laptop, on your desktop, or your phone, there is a chip which we all know it is called the processor embedded in there, and that handles all the processing work. We most of the time refers to it as the central processing unit or CPU. So that is the microprocessor. It handles the functionality, the processes, execution of tasks, and everything that happens inside your system. What of the microcontroller? This is it here. This can be embedded in other devices, which we are going to learn more on that. Your watch, there is a chip, an integrated circuit embedded in it. That is a microcontroller. Even calculators, the Casio calculators we have, there is a chip inside that is embedded in it. So for now, let's look at a microprocessor or a microcontroller as the brain of the computer or the hardware system. So how do they function? Okay, these chips or integrated circuits get instructions that are stored in the computer memory. Now, when they get these instructions, they decode or translate the instruction. They now process the instruction and execute the output. So this is how the system works, the microprocessor or the microcontroller. So they can either function as a whole, just like you have in your computer or in your phone and other devices, or they can function as an independent unit. That means they can function without anything being attached to them. They function very fine. We are going to look at examples of how this can be implemented. Now, first, let's look at applications. Okay, last week, even the first speaker mentioned about IoT systems, how they are being interconnected to each other. So I remember last week I discussed about how you can connect your home appliances like your television, your sockets, your microwave, fridge, whatever you can think of, even your whole house to a cloud. And then it's being managed there. You can even stay in your office and get real data of what is happening at home. So now, for these devices that are connected together, there is something that is propelling their motion, that is making it to function. And that is a microchip or an embedded system. Now, you look at in the manufacturing equipment, we have those motors like milling machine. We have other machines that are used in the manufacturing industry. Those machines functions very smart because of the embedded chip, the integrated circuit, either a microcontroller or a microprocessor that is being used inside there to make it look smart. Now, if you look at like cameras, they also have a chip inside there that is making it to function very smart. Your domestic appliances, your cars, medical devices, even telecommunication equipment, like you do see telecommunication masts located around where you live. They have microchips. These devices, they are all embedded inside these systems. Gaming consoles, like all those game consoles we do buy. I remember one small toy I used to use to play game back then. So there's a microchip, an embedded device inside it. And this is actually the driving force of this system. So the whole point is you need to have knowledge of how to program or to make the system work. Understanding a microcontroller or a microprocessor is very, very important in this career of IoT. Because without the knowledge, a perfect knowledge of how the system works, you may not be able to continue. So you need to understand how to program these systems, how to design them. So with that, you now understand how the functionality works. So a clear knowledge of this system is very, very important. Now, we look at classification of embedded system. Embedded systems can be classified based on performance of the microcontroller and the functional requirements of the system. Let's look at a further classification of these two definitions. Based on functional requirements, we can further classify it into 4 areas. That is the standalone embedded systems, real-time embedded system, network embedded system, and mobile embedded system. A standalone embedded system is an embedded system that does not need any other attachment. It can either stand on its own, you program it, it functions without any attachment for it to function. Whereas if you're looking at real-time embedded systems, these are systems that function as events occur. For example, let's look at, you want to measure, okay, you want to constantly be getting how a process is moving. Let's say, for example, you are in an industry and there's a particular machine that is producing a waterproof. And this machine has to be cutting this waterproof in a precise point. Now, you need to be getting the live feed of how this process works. If there is any bad one, it has to push it aside. Now, what is happening at that moment? Real-time embedded system handles that. So you can classify it based on that functional requirement, how we want it to function. On network embedded systems, Now, if you look at network devices like router, switches, hubs, inside these devices, there are microchips embedded into it that makes it to function. So if you look at your mobile phones, well, we cannot overemphasize these facts. Like your mobile phone has a microprocessor, and this microprocessor is what is actually controlling every process that is happening in there. We can also classify the embedded system based on performance of the microcontroller. We have small scale embedded system, medium scale embedded system, and sophisticated embedded system. In terms of small scale embedded system, that has to do with the memory capacity of the microcontroller you are using. Now, the chips I showed you, those microcontrollers, they have memory sizes. The amount of data they can store, they can process. Now, the small scale embedded system, since memories are being classified in terms of bits, 8 bits makes up 1 byte, and informations like the character you are seeing in my computer screen can be represented in forms of bits or bytes. So like one character, 8 bits. Bits, I mean zeros and one, binary counting. Now, because you know that we humans in numeral systems, we count in decimal 10 from 0 to 9. But computer does not actually understand these numeral systems. So every data is converted into binary, zeros and one. That is base 2. So that is how microcontrollers process information. So a small scale can be a microcontroller that has an 8-bit processing speed, or microcontroller, 8-bit microcontroller, 16-bit microcontroller, 64, 32, 128, 256. So this bit separation or classification help us to see which of the microcontroller is of small scale, medium scale, or sophisticated microcontroller. And in this case, depending on the type of application you want to design, if the application requires a lot of memory, you now need to know what type of microcontroller you need to design that application. So either to choose medium scale, small scale, or sophisticated one based on memory. And that also determines the performance of the system. Now, let's look at examples of an embedded system. So first, we want to look at elevators controller. Now, in tall buildings, you notice that there is an elevator that can take you from the first floor to the last floor or to any of the floor you want to go. What do you think is actually driving those elevators? Likely you say there is a motor that is driving the elevator up and down. Well, that is true, you are right. But before the motor, there is a controller that is telling the motor the specific floor in which the elevators is to stop. So this controller can either be a microprocessor or a microcontroller. It tells the motor the specific floor when a particular button is being pushed. That controller is an embedded system embedded into the elevator. Now, you, as the designer, you are the one to sit down, write programs for this system. You program it, you tell it what to do. Whenever it receives an action, what is this action? The action is a button you are going to press. You press a button, that is an action. Something should happen. The motor should move at this particular floor. You design it, program it, give it the instruction, and it functions as you want it. Let's look at another example. This is satellite television decoder. Well, you notice that we have DSTVs, strong, high TV, and other ones located in our homes. Now, this dish do receive signals from the satellite. Now, inside your home, there is a decoder, a satellite decoder that is able to take this signal that is being received, translate it to the information your television can understand. What do you think is inside that decoder that is able to understand the signal that is coming in from the satellite, transmit it and interpret it to what a television can understand and display, and you can watch TV, football, and other things? It's a microprocessor or a microcontroller, and that system is embedded inside the decoder. So that is a clear example of how a microcontroller or an embedded system work. Now let's look at your phone microprocessor, okay, which I've talked about this already. That inside your phone, there is a chip, a microprocessor embedded inside the phone. And this microprocessor is acting as the brain of the phone, and it processes all information it receives. So the work of an embedded system engineer is now to design the system and to program it to make it function. And two, your card readers, maybe you go to bank, some bank, they require card to allow you access to the bank, or maybe in an office. And two, MP3 players, digital camera, traffic light, airplanes and cars, whatever electronic device, mechanical device that is smart you can think of, there is an embedded chip inside there that is making it to function as smart as it is. And that is an embedded system. And your work now is to design it, to make it function. And that requires programming the system. So a good understanding of how programs work is very, very important in this field of IoT, that is Internet of Things. A good understanding of how to program is very, very important. With this, you can excel in other fields like what the first speaker mentioned, into the web, Android app. With the knowledge of programming, you can move into other fields. So sometimes you may be confused where to start first. Start from the one you can do now. Maybe you can start learning programming languages like C++ or C to help you design embedded systems. With the knowledge of that programming knowledge, more opportunities are open for you to learn more things like web, Android. This, you will then integrate them together to build a larger system forming an IoT. So programming knowledge is very, very important. It's crucial for you to understand this. Now let's look at the components of an embedded system. We have the hardware components, and well, this refers to the physical part of the system that we can see, like the microprocessor, the microcontroller, your phone, the hardware part that you can touch and see. This is the hardware component. An embedded system has this hardware component. A hardware component cannot just stand on its own and function without something driving it. And that driver is the software component. So this refers to the programs or instructions stored in the computer memory that enables the system to function. An example is a small program you can see here on the screen. Now, this is just a C++ program to read a number and a character from user and print it on a screen. You see, just a little program like this, you can instruct a microprocessor or a computer to do a particular function that you want it to do. You read the integer, the value from the screen. Then after reading the inputs, then you write it back to the terminal or the console or the screen where you can see what the user enters. So this is just a typical example of how to write programs, how programs work. They are just instructions you give to a computer. You tell it what to do. Remember, computer doesn't understand plain English, the one we are speaking. You have to give it the instruction it understands. So you have to study the instruction the computer understands and give it to the computer. So the microcontroller and the microprocessor, they all need this to function. You as an embedded system designer or an IoT engineer, you need a deeper knowledge of this system. Another component is a real-time operating system. So this system provides the microcontroller with the ability to respond to inputs and complete tasks given to it within a specific period of time based on priority. So it defines the way the system works. So now, if you look, when you are looking at a real-time operating system, the microcontroller responds to input, complete the tasks, and these tasks are being given based on priority. So that is how the system works. Now, let's look at other functionalities or characteristics of an embedded system. Single function, tightly constrained, and it can also be reactive in real time, must be a microprocessor or microcontroller based, must have memory, and also must have peripherals, and the system must have hardware and software parts too. When you're looking at single function system, it's a kind of system that performs operation repeatedly and tightly constrained, has to do with the memory part of the system and the size, the cost. So microcontrollers or microchips, they have to be very small because of the application. Now for this, their design has to be small. Their memories are small. So you need to know the application you are using it for so that you'll be able to select the kind of system that best suits for you. Even they consume less amount of power and they have very small size. You see the one I showed you, they are a very small size. Even there are microchips that's very tiny, very, very tiny. Most of them are tiny and they must be reactive in real time. That is, they must respond to events that is happening in real time at this particular moment. If something is changing, take for example, maybe you are monitoring the temperature of a room. As the temperature is changing, the microcontroller has to be working in real time, responding to those changes, reporting back to you. So most of the time they are designed based on this specific functionality. And two, this system has to be a microprocessor or a microcontroller based, because without it, embedded system will not be really that smart. You need these microchips for them to work very fine. They must have memory too, and without memory, you would think of where to store the data, so there is nowhere. They actually, microprocessors and microcontrollers have some specific differences, though we are not going to look at that for this course. That will be next week. We are going to look at more in-depth of microcontrollers and microprocessors. But for now, let's look at their characteristics and what they really have. Okay, they must also have hardware and software parts. We've discussed this before. Now, advantages of an embedded system is easily customizable. You can customize it, reprogram it, make it function as you want, low power consumption. Those small chips, they don't consume much power, just a few milliamps or microamps that they consume, because current is rated in terms of, or power is rated in terms of that wattage. So now they consume low power and they are low cost too. You can get them just a few thousand, like most of them, the 80 mega 328p, 80 mega 2560. So these are some microcontrollers with 5,000 naira, 4,000 naira, 3,000. You can get these chips. So they can also perform very, very fine. So they have an enhanced performance. So a good knowledge of how the system works is very, very important. Now let's look at the basic structure of an embedded system. We have sensors. Now this sensor is attached to our analog to digital converter. The sensor like a temperature sensor, motion sensor, smoke sensor, whatever you can think of, whatever you want to measure. Is it pressure? Do you want to monitor like how process changes? There are sensors for these systems. So now, if you attach a sensor, have in mind that these sensors are reading analog data. The analog data are data. They are actually measuring the physical changes of our environment or the process you are monitoring. That is what the sensors are doing. And two, now any of the changes they measure, they convert it to electrical signal, and this signal is analog. It can be analog and digital. Know that if it is analog signal, electrical signal, it changes continuously like a wave that changes up and down. Then this signal, for it to be processed by a microprocessor, it has to pass through an ADC. An ADC is an analog to digital converter. An ADC is an analog to digital converter, which you can see here. And the processor process the information. Let's go back here. Then we are going to look at those definitions more in depth. Now, when this information is converted to a digital signal, it will be fed to the processor. But before then, the sensor records or reads the information, converts it to analog. It will store it in the memory for further process. Now, after converting from analog to digital, the data will also be stored in the memory. Now, the processor gets the data either directly from after conversion or from the memory, then processes the information. They give it back to a digital to analog converter. It will be converted back to an analog, that is a system that changes. Then an actuator is the output. Either it can be referred to a motor or a light. They will function based on this. But now the question you may have is, why do we need all these systems to function together for the processor to work? Now, real world events is not digital, it's analog. Like the changes you have in your environment, the processes, temperature, pressure, all these systems, they are all analog. The changes continuously. Now, the microprocessor or the microcontroller cannot work with such data that changes continuously, but rather they require zeros and one, discrete form of data. Now, this data has to be converted from analog to digital for it to function, so that the microprocessor will process it. After processing, it will then convert it back from digital to analog, from digital to analog, so that it will be used to drive actuators, either motors or other systems. Now, let's look at, okay, I've already mentioned definitions of a sensor, which measures the physical quantity and converts it to electrical signal. Then it stores that in the memory. Okay, so this is just an example of a temperature sensor. We have analog temperature sensor and digital temperature sensor. Okay, now the good part of the digital temperature sensor is that inside of this sensor, an ADC is integrated to it. That is, analog to digital converter is embedded in it. So immediately reading the analog data, it converts it to digital before feeding it to the microcontroller. So while another sensor is a smoke sensor, which is, you have seen the component there. If there is any smoke, like maybe there's a fire outbreak, fire most of the time starts with smoke, and this sensor can actually detect the smoke and alert you so that you come and do something about it before the fire outbreaks occur. So this is like good scenarios of implementation of this system. You can actually detect the smoke before fire outbreak. So this is a water level sensor, which you can use that to know the level of water. Maybe you are working on a project. Let's assume maybe you are designing a kind of system that will automatically check when water levels of your house, like a tank in your house, goes down. And if it goes down, the system will automatically pump itself. The water will pump back to the tank and fill up the tank. You don't have to be on the pump by yourself manually. So the system has to automatically function. You put a water level sensor. It senses the level of the water. If it gets down to the lowest level, it will trigger, send a signal to the microcontroller. The microcontroller picks the signal and sends it to the motor, the motor that will pump the water. It will automatically pump water and fill up the tank without you even knowing. So you don't have to be worrying about, water has finished. You make your home smart with these devices. This is the good part of this system. Now, we've discussed analog to digital converter. They convert the analog signal to digital signal, while the processor does process the information, store it in the memory, and give out the output. While digital to analog converter does the reverse part, because real-world processes don't work with digital signal. They need analog signal, so it has to be converted back. So this is an example of an actuator. So an actuator just compares the outputs given to it by the digital to analog converter, then to the actual output, then store it in a memory and processes the output. You may wonder, is LED an actuator? Yes, an LED is an actuator, but it's a digital actuator. It can also function as an analog actuator too, because you can turn it on and off with a digital signal like zeros and one. You can also dim light with analog signal. We call that pulse width modulation, or PWM signal. Motors, you can see here, they are all analog signals. Sorry, actuators, sorry. So they require analog signals to function. You can vary the speed of the motor, how fast it drives. This doesn't require digital signals that are either zeros or one. No, they need continuous changes signal. With that, you can vary the width, like that is the speed of the signal. Even loudspeakers too. All these are actuators, the output of a microcontroller. So that is a basic system of how embedded system is being the architecture. Well, we are going to learn more about this next week. And next week will be all about looking at the architecture. We are going to see more in depth on the difference between a microcontroller and a microprocessor and the functionality. So this is just the basics. Understanding the basics will help you to advance more when you go to the system. So please, if you have any question, you do well to indicate. You have any
All
questions?
right, thank you so much, Mr. Sunday, for that wonderful teaching. I hope we've learned a lot too. We've learned a lot today. So, is anybody there with a question? Want to see a thumbs up? Want to see a hand raised or whatever? So let me just see questions, because it's now becoming interesting. We are no more doing the what if anymore. We are now going back to what the real thing is all about, the real thing, the main purpose of this class. So, is there any question? Oh, I'm still checking my chat now. So, okay. If there is a question, I'm going to ask one question. All right. Am I free to ask? Am I free to ask? I hope I'm audible enough.
Yes, sir.
Oh, I'm audible enough. Okay. So, okay, I'm saying Patrick here says that we're waiting for the video of last week class to come out because some of us were not available. Okay. Mr. Patrick, we are going to try and make that video available. on YouTube. So just watch out. But for the meantime, just follow through with what the first class was just basically a pure introduction. So just simple, what just basic, what is this and what is that? That's what we did in the last class. So but we are going to make that class that video available for you. So any other question? Any other question? So now my question is, a device that measures the physical quantity of an environment and then converts it to an electrical signal. What's that device called? I've seen Edidion selecting here. Edidion selecting, do you want to ask a question or do you want to answer the question?
I want to answer the question.
You want to answer the question? All right, go ahead.
It's a sensor.
Oh, it's a sensor. So I'm getting the first, who is this? Ferrami. Am I getting your name correctly? I've seen Ferrami first. So that's going to be okay. Okay, Ferrami, all right, thank you. And then a Didium, all right, thank you. So it's basically a sensor. It's what rates your physical data and then convert it to electrical signal for you. Okay, so without taking much of the time, please just always be watch out on the channel because we'll be dropping a lot of questions there on the channel, and your promotion from one particular level to the next level is going to be based on answering some of those questions we drop on the channel and even the question we drop here. So that's going to be, we're going to try to take a statistic of, okay, how frequent you're able to answer the question. And then although there's going to be some assessments at some point or the other, so that we can take it to the next level. All right. Was that audible now?
Yes, sir.
Okay, okay. So will there be any other questions? And then what I would like to ask is, what's from the class of today, okay, what's your view about IoT? What's your view about IoT from the class of today? What do you see IoT to be? I have a chat here. I have a participant seeing through something. So can I call some names? Can I call some people to answer the question? Hello, I hope you can hear me. Hope you can hear me loud and clear.
Yes, sir, we can hear you.
Okay, so I asked a question from today's class. What's your view about IoT? From what we've defined, what IoT is all about, what it can be used for, the careers we need, the opportunities we need. So, what do you think IoT is? Because this will help fuel your passion towards it. Okay, so let me call someone here. So I'm seeing Emmanuel here. Okay, I've seen answer from Patrick said IoT is the means in which devices can communicate with each other through Internet of Things. Okay, through Internet of Things. Okay, so at this point, I think I'm going to open up the floor so that you can speak up. So I'm seeing Patrick first. So Patrick, you can unmute yourself and then speak. Mr. Patrick, are you there?
can't speak.
Okay, sorry, we didn't get you right.
My network isn't that steady, so I'm chatting.
Okay.
That's why I'm using the chat this and I can't
Okay,
speak. Yeah.
okay. So let me read out your chat here. So your chat says IoT is the means in which devices can communicate with each other through the internet. All right. So Ms. Emmanuel also said that system comprising of hardware, software, and real-time monitoring devices used to store data in the cloud and also communicate between devices. So okay. So I'm getting your point. So Unique says that IT deals with both hardware and software, software system, both hardware and software system. Okay. So let me see, the IoT will always be relevant and needed because everyone wants to bring things, wants things to be smarter and easier. Yes, I really agree with you because like me, I love smart things. So I don't want to put too much energy in doing one particular thing. I want my thing going on as fast as possible and as smart as possible. So okay. Do I have one other person who wants to say something about IoT? What do you understand by IoT from today's lesson? Do I have one other person? Okay. So in the absence of any other person, so we'll end the class for today. So please, like I said, we'll be dropping questions on the channel, and then the way you answer the questions and how you engage is going to be part of your assessment. And when once you get into like the second month of the class, it's not going to be all theoretical like this. So get your laptop ready. Get your laptop ready. All the things needed to be, all the software needed to be used will let you know. We'll drop it on the channel so you get to see that. So it's going to be a hands-on. Okay, in the subsequent next month, it's going to be a hands-on. So you do what we do just the same way we're doing it, and then you'll be able to get it through. Okay, so Unique, you said you have a question. So can you unmute yourself and then ask the question?
Okay, thank you very much, sir. The slide that was used today, can it be dropped like as a document for us to just review?
Okay, yes, the slide is going to be dropped on the so look, it's going to drop on the channel, so you can see that there.
Thank you, sir.
All right. So like I said, in the next month, the games will up. You'll notice that today's topic is different from what we did the last time. So next class, the game will up. So I expect you to sit up, and then if you have any questions, just drop your question on the Slack channel, and I'll be there. The trainer will be there, and other mentors who are in that Slack channel will be watching out. And then the link to IoT Tech Quest will also be dropped there. So there is just for people who are really passionate about IoT and really want to do a lot in IoT. So you go there and interact with a lot of mentors that are there, and then you get your answers for any questions you ask. So I'd like to say very, very thank you to you all for joining the class today. I'd like to say a very big thank you to Gideon Celestine, Mr. Emmanuel, Mrs. Ferrami. I hope I'm correct. Femi, Odoro, Okoro Victor, Sole, if I'm pronouncing your name not good enough, please pardon me. And teacher, trainer for today, Sondemba, Unique Star, and Richard Akwabi. I want to say a very big thank you to you all for joining the class today. And please, let's just keep a date next same time. 5 o'clock to 7 o'clock is when we have a class, and then just join on time so that you won't be missing any of the things. Just I think I got a message. Someone asked what was done maybe the first few minutes. That means you didn't get my presentation. So try to join on time, and then you'll be able to get everything clear. So thank you very much for joining today, and we'll see you in the next class.
Thank you all. Have a good night rest.